So chapter 10 is our last chapter. We're looking at the sign test. The sign test is kind of just a simplified hypothesis test. So the theory is the same. We're going to be looking at a known alternate and deciding which one we're going to side with. How we make that decision is a little different. So here are two examples of the sign tests. And we're looking at the basic sign test. And there's two different types. There's a dependent sample and one that's on a test a median or mean. So today we're looking at the dependent samples, and tomorrow you look at the mean and median. The only difference or the only rule you have to go by for this is the sample must be 25 or less. So again, this is a very simplified version of a hypothesis test. So here's our example. The problems all look the same. We're looking at the dependent samples. Does a SAT prep course improve your score for math? And I have 95%, meaning I want to be 95% confident. So just like before, you all start with the null and alternate. So if we're looking at if it's improving our scores, that means the after is going to be greater than the before. So our null and alternate, the null is the mu before equal mu of after. The alternate, the mu before, is less than the mu of after. We think the after is going to be higher, and we're seeing if the prep course is going to do that or not. Now, instead of comparing a p-value and an alpha level to decide if we reject or fail to reject, we're going to look at a test statistic versus a critical value. So the way you find your test statistic, we're going to focus on that first. You need to count up positive and negatives. And what we're going to do is look at each pair here. We have 650, 720, 580, 820. And we're just going to subtract them and see would we get a positive or negative number. I don't care as much about the exact value, but I care is the value positive or negative. So if I go through this, 650 minus 720, that would be a negative value. 580 minus 820, negative value. 550, 550, that would give you 0 if you subtracted it. 490, 580 is another negative, and you would just keep going. That would be a positive. 670 minus 650 is a positive value. 650, 620, positive value. 480, 600 is negative. 550, 620 is negative. 556 and 639 is negative. And again, I don't care about the value, I care about positive and negatives, and that's what I want to count up now. I want to count up how many positive signs, 2 positive signs, and there were 6 negative signs. Kind of just ignore the 0 for right now. Now, one of those is on to your test statistic, and the rule is the test stat is the less of the 2 values. So in our case, we have 6 and 2. Our test stat is 2. Okay, so there's one value that we have that we're going to be comparing to decide if we reject or fail to reject. That is our test stat or our test statistic. The next piece is the critical value. So the critical value is going to be off of a chart that you're going to need to print out or at least have on your computer or phone so you can look at it. That chart needs the alpha level, and it also needs your degrees of freedom. We didn't really talk too much about the degrees of freedom, but so now we do need to know what the degrees of freedom is. The degrees of freedom in this case is n, and n is the number of pairs that you have. So if you go back 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs. So our degrees of freedom, df equals 9. You also have to know if we are looking at a one-tail or two-tail test. And the way you want to determine if it's one-tail or two-tail is you look at the alternative. If the alternative is less than or greater than, it's one-tail. If the alternative is not equal to, it is a two-tail test. So the alternative is very important to get correct. It tells you one-tail or two-tail. So if we go back again, our known alternate, we had less than. So we're going to be looking at a two-tail test. So if we go to the chart now, so it's important we have our degrees of freedom is n, n which is 9. We know we're looking at a one-tail test, and our alpha level was 0.05. Since it was 95% confident, our alpha level is 0.05. So if we're looking at this chart, it's very important you look at one-tail, two-tail, make sure you look at the right value. Here we're looking at the alpha level, so 0.05 one-tail. So this is the column we're looking at. Our degrees of freedom, n, is 9. So there's 9, go across, 1 is our critical value. So again, we had our alpha level 0.05, 1 tail. We went down to n equals 9, and 1 was our critical value. So if we're looking at this now, we have our null alternate, we have our test stat of 2, critical value of 1. Now it's time to make our conclusion. If the test score is less than or equal to the critical value, we would reject the null. If the test stat is greater than our critical value, we would fail to reject the null. Okay, so that's what we're looking at. And in this case, test stat is 2, critical value is 1. So since our test stat is greater, we would fail to reject. So your conclusion now is going to be extremely similar to what we have been writing. Okay. Since our test stat is greater than our critical value, we would fail to reject the null. That means that we're outside with the null, so it means that we're looking at before and after averages are equal to each other. So just another sentence then, before and after the prep course, the SAT scores are the same. They're equal to each other. So something along those lines is what your conclusion should look like. This is the final screen. This is what your final answer should look like. I'm going to expect to see your null and alternate, your test stat, your critical value, and your conclusion. Those are the 4 pieces I'm going to need for your final answer for these problems. Okay, so the next video is just another example of the dependent sample, so take some time and look over that.